once again demonstrating his extraordinary dedication to the realm of physical sciences. Michio Kaku has recently verified that the James Webb Space Telescope has discovered 6 massive systems that researchers once thought could not exist. These findings have the potential to enhance our scientific comprehension of the cosmos. This revelation is both thrilling and groundbreaking, challenging existing theories regarding the formation and development of galaxies. Therefore, it is crucial to closely observe these advances. The endorsement by such a distinguished expert emphasizes the significance of these discoveries. Michio Kaku is a notable figure in the scientific world, a Japanese-American physicist. He is acknowledged as an authority in both classical experimental physics and quantum mechanics. Unlike some more traditional and skeptical academics, Kaku has been receptive to the remarkable results of the James Webb Space Telescope mission. His openness to accepting novel discovery and sharing them with the public highlights his commitment to advancing our knowledge of the universe. We are delighted that this esteemed researcher has decided to speak out and reveal what can no longer be ignored. The excitement and almost playful tone of the renowned theoretical physicist are apparent in his comments about the discovery made by the James Webb Space Telescope, indicating that this has been an event that has captured his attention. Join us as we examine the consequences of Michio Kaku's statement about these 6 colossal galaxies. Kaku is a researcher who has always been willing to consider fresh ideas. Throughout his career, he has shown a willingness to entertain concepts that challenge established convictions, recognizing that Einstein's theories of relativity and Newton's laws, while foundational, are inadequate to fully account for the complexity of the universe. Kaku understands that the new telescope's revelations have the potential to enrich the scientific field. Although many of his peers have struggled to accept this perspective, it has sparked concern and discomfort among both supporters and detractors of quantum mechanics. Nevertheless, this only amuses Kaku. The James Webb Space Telescope has uncovered the existence of 6 enormous galaxies from the earliest stages of the universe. Each of these galaxies contains more stars than our Milky Way, despite having formed only a short time after the Big Bang. The group of astronomers responsible for this discovery has named these magnificent galaxies universe breakers. If confirmed, they would completely transform our understanding of the cosmos. The consequences of these findings are profound, suggesting that the universe's early years were much more intense and complex than previously imagined. The theory of how things originated suggests that the universe was a chaotic mass. Following the initial event, the formation of the first solid objects took countless years, and it required additional time for these objects to achieve sufficient density and emit light. The creation of complex structures, such as galaxies, was thought to take place much later. Some of the newly discovered galaxies exceed the Milky Way in size, and their immense brightness suggests they were likely forming numerous new stars each year. While our universe forms stars intermittently, it remains unclear exactly when the first galaxies appeared. Scientists have been unable to pinpoint this until now. The only certain fact is that initially there may have been only single stars or star clusters that eventually merged to create increasingly larger structures. Until dwarf galaxies formed, these smaller galaxies encountered other galaxies and gradually grew. Previous theories claimed that highly organized and massive galaxies could not have existed at that time, raising the question of whether the universe is much older than we previously thought, or if complex cosmic structures emerged much Earlier, this scenario is challenging for traditional science to accept, which continues to grapple with this model, and some elements of physics strongly resist action in this discovery, questioning possible errors in the age calculations. Kaku is aware of this and has said there are many examples of outdated and incorrect theories that stubbornly persist due to the prominence of certain researchers. Many of these theories were only disproven when crucial experiments revealed their falsehood. Therefore, the most important aspect of any science, especially in physics, lies with the experimentalists who keep scholars informed of the facts. On Earth, we have barely any insight into the true origins of the universe. This statement from Kaku highlights the necessity of continuous experimentation and verification in the scientific method. The theory of the universe's origin was proposed in 1927 based on observations of the universe's expansion. This data led to the conclusion that the universe began from a singular point and has been expanding ever since. At the time, it was difficult for people and researchers to imagine a universe with a beginning and an end. The concept of a universe that had always existed and was infinite in size was beyond comprehension. Even today, scientists still struggle with this idea. However, it is vital to entertain these possibilities. These new discoveries do not align with what scientists have relied upon for a long time in explaining how things came to be. Nevertheless, science has consistently shown that revision and openness to revolutionary concepts are essential elements of the scientific process, as is the confirmation of specific theories and observations. When Einstein was a child, it was believed that the stars and planets were permanently fixed in the universe and that these specific arrangements occupied a defined space. However, we now know that everything in the universe is in motion. Planets orbit stars move within their galaxies at speeds of many kilometers per second, and entire galaxies travel swiftly through the cosmos, the destiny of which we cannot yet predict. This evolving understanding of the universe challenges long-established beliefs and underscores the need for ongoing inquiry and flexibility in scientific thought. Today, scientists are faced with the challenge of accepting uncomfortable truths and understanding that theories are not absolute truths until they are rigorously tested or confirmed by accurate observations. The concept of the Big Bang arose from the realization that galaxies are moving away from one another, and this distance is proportional to their separation from Earth. This observation, known as Hubble's law, suggested that the universe was expanding for many years. Factors such as cosmic background radiation, the red shift of light from distant galaxies, and other cosmological phenomena appeared to support this theory. However, it is important to recall that in the past, people who believed the Earth was flat and that the Sun revolved around us also had empirical evidence for their beliefs, until events or technological advancements revealed a clearer and more precise picture. Currently, we are in a similar situation. Researchers expected the new James Webb Space Telescope to confirm the assumptions related to the Big Bang, but instead they have encountered these 6 galaxies that seemed improbable. This teaches us that science is constantly evolving and that researchers must be open to new discoveries and reassess existing theories based on the available evidence. The unexpected results challenge the current understanding and prompt a reconsideration of long-established cosmological models. Scientists use redshift as a tool to determine specific quantities in the study of the universe. Redshift, also referred to as the Doppler effect, is the change in the color of light as the light source and the observer move in relation to each other. To understand this, you can imagine stopping and hearing a vehicle approaching you as the vehicle moves. Toward you, you hear the engine growing. Louder, however, once the vehicle passes or moves away from you, the engine sound shifts. The same principle applies to light. When a light source such as a distant star moves toward us, the light we observe shifts to bluer hues. Conversely, when the light source moves away from us, the light shifts to redder hues. This phenomenon is known as red shift. Physicists have converted red shift values into speeds and distances for measurement in the study of the universe. However, it is crucial to note that small errors in these measurements could have significant effects. The measurement methods previously employed are now under review. Given the most recent observations concerning our universe, it is essential to consider whether they are genuinely based on red shift errors or if some researchers are simply rejecting the facts. This is a question that requires careful investigation and a thorough review of the data and methodologies used in the research. The current analysis and reassessment of measurement methods highlight the evolving nature of scientific inquiry. Thank you for watching the video. As always, we encourage you to post your questions in the comments section. If you enjoyed the video, remember to click the like button, share it so it reaches more people, and subscribe to the feed so you don't miss more content like this. Thank you for watching, and we'll see you in the next one. This call to action urges viewers to engage with the content, fostering a community of curious minds eager to explore and understand the latest scientific discussions. The exploration of our universe with its vast stretches and complex celestial bodies continues to captivate and challenge researchers worldwide. From early theories of the universe to the most recent breakthroughs made possible by cutting-edge technology, each discovery reshapes our understanding of the universe and pushes the limits of human knowledge. One of the most significant and enduring questions in cosmology revolves around the origin and evolution of galaxies. Galaxies are like cities of stars, gas, dust, and dark matter bound together by gravity. Understanding how galaxies form and evolve is crucial not only for unraveling the mysteries of our universe, but also for confirming or testing existing theories such as the theory of the universe's origin. The theory of the universe's origin, proposed nearly a century ago, suggests that the universe began from a singular, infinitely dense point and has been expanding ever since. This idea arose from observations of the universe's expansion and the cosmic microwave background radiation, regarded as the remnants of the early universe's intense heat and light. However, recent discoveries, particularly those made by the James Webb Space Telescope (JWST), have questioned several fundamental assumptions underlying the theory of how things came to be. The JWST, with its exceptional sensitivity and resolution, has detected galaxies that appear much more massive and advanced than expected for their age. One such discovery involves 6 enormous galaxies dating back to when the universe was only 200 to 700 million years old. These findings by the James Webb Space Telescope raised significant questions about the early universe and the theories that have long shaped our understanding. As astronomers and physicists explore these findings further, the scientific community faces the challenge of reconciling these surprising observations with established cosmological models. The consequences of these discoveries could lead to a profound revision of our understanding of the universe's origins and evolution, emphasizing the importance of continuous exploration and openness to new ideas in the pursuit of knowledge.